So we have our layout lines that we just did, and we have it punch marked. Now this is the point where we put our workpiece in our machine vise. We put our tools in our machine. We're going to line up the punch mark to the drill in the machine. And then we're actually going to perform the drilling operation. So first, let's put this in our vise. So I'm going to put that in. Now you want to make sure when you're drilling that you're not sticking out over the end of the vise. The way I have that in there right now, when I start drilling, the force of the drill is actually going to want to tip the workpiece down. So that's not a good setup. You want to make sure whatever you're drilling is inside the vise. So close your vise, tighten the handle, and then make sure the vise is on the left side like this. If you're standing here, you want the vise to be on your left-hand side. So if something happens and this vise starts to move, it would hit this column before it comes all the way around. So now we have to put our tool in the machine. This is the drill chuck. Make sure the taper is clean. Make sure it's clean on the inside of the machine. Line up that tang and then snap it in. The first tool we're going to use is a center drill. Now center drills are typically used on a lathe. It's a special drill with the 60-degree taper to match the lathe taper. For today though, we're just going to use the tip of the center drill. And what we're going to do with this is we're going to come over to where the punch mark is, and I'm going to have to line up the center drill in our punch marked hole. So first I'm going to put the center drill in the machine. Remember to tighten the drill chuck, at least in 2 places. So our first tool is a center drill. It's made out of high-speed steel, and it's going to be cutting mild steel. So if you look at your cutting speeds chart, the cutting speeds for mild steel with a high-speed steel cutter is 80 to 135. So let's just use 80. We have to apply it to the formula. 80 times 4 divided by diameter. Here now, it's the tool bit that rotates. So this is the diameter we're talking about. The tip of that center drill is about 1/8 of an inch. So our cutting speed is 80 times 4 divided by 0.125. So 80 times 4 divided by the diameter of 1/8 of an inch, or 0.125, tells us our RPM can be 2,560. So now at this point we can set up our machine. Our calculation says 2,560. If you look on our charts, the highest number I have is 1,524. So that is in this first green column. So this arrow points to that green column. And it's the bottom row of numbers. So I need this arrow to point to this red line. So now I have this red line and this green column, so I'm at 1524. So now at this point I'm going to be sliding the vise around underneath the tool. I'm going to bring the quill down until the tool bit gets near the material, and I need to line up that center drill to that punch marked hole. When you're doing this, always check it in 2 directions. Check it left to right, and then move around to the side and check it front to back. And make sure that that lines up with the punch marked hole. Also make sure that you're not too far away from the column back here. You want your vise to be within 1 inch of this column. So now at this point we can start the machine. Remember, the top one's reverse, stop, this one's forward. Now slowly feed the quill down into the workpiece. So after you have the hole center drilled, you want to change tools. Take out your center drill, put in your 5/16 drill. Remember to tighten at least 2, if not all 3 holes. Now this tool is a 5/16 diameter tool, so we'll have to recalculate our speeds. It's still a high-speed steel tool bit in mild steel, so the cutting speed is still 80. So we go 80 times 4 divided by the diameter. The decimal of 5/16 is 0.3125. That tells us our speed needs to be about 1,000 RPMs. So just keep in mind that every time you change tools, you have to change your RPM. So we need to be 1,000, it says 1,024 on the calculator. Our drill press has 1,026. So that will be in this green column. So with this arrow. And we need to be on the bottom row, which is this red line. So that's where it's at right now. Go ahead and bring your quill down, make sure it's still lined up. And when we drill, I'm going to use a little bit of coolant here. I have coolant in this spray bottle, and while it's drilling, I'm going to keep it, I want to keep the tip of the tool cooled down and keep the hole lubricated. I'm going to start the machine. And now when you're drilling, you want to put enough pressure down on the drill that it makes a continuous chip. Now you notice I keep stopping while I'm drilling. I'm stopping so that I can put coolant in there, and it also keeps my chip shorter. You don't want long stringy chips. Long stringy chips are very dangerous. Now you're going to notice you have to put pretty good force on there to drill it, but as it breaks through the bottom, it's going to start drilling quite easy. So just be careful that as you get to the bottom of the hole, that you lighten up on your feed rate. And now I'm all the way through. So just keep in mind that as you're drilling and you get through to the bottom of the hole, it's going to drill easier. So lighten up on your feed rate, otherwise it's going to want to break your drill bit off. So after a hole is drilled, there's other things you can do to it. Sometimes a drilled hole is accurate enough. Other times you'll be putting a tap in that hole to create an internal thread. You may be doing a counter bored hole. So after you drilled your first hole, a counter bore would enlarge the hole on the top, usually to accommodate the head of a screw. We could be doing a countersink or a reamed hole. One thing to keep in mind though, if you do any other process on this machine, besides drilling, it's considered a forming process. Reaming, counter boring, tapping, countersinking, those are forming processes. So when you do a forming process on a drill press, you want to make sure that on your chart you follow the forming speeds. So I'm doing mild steel with a high-speed steel cutter. I would have to go 40 surface feet. So 40 times 4 divided by the diameter of your tool. Drilling is the only process in the machine on the drill press that you'll use 80 surface feet. Everything else is considered forming, so that would be 40. After you're done using the drill press, make sure you clean up your work area. Now don't use your fingers or an air gun or a blow gun to clean up the machine. Take a paintbrush or a chip brush, brush it down onto the table, brush everything off into a dustpan, and throw it away. Make sure that you clean up the area around you. A lot of people forget that on a drill press, the chips are actually flying all the way around you. So you'll have to clean up an area probably 5 feet all the way around this machine when you sweep the floor. So just keep in mind that you're working safely and that you keep a clean work area, and make sure that you clean it up better than you found it. That's a good rule to use in a machine shop. If you have any further questions about the drill press or you want to see the other processes, just see your instructor and they will demonstrate that for you.